So what I'm going to be asking you to do, it's not going to be something very complicated, okay? So like in the case on the screen you see now, lab number 5, did any of you had a chance to complete the Zener Diode lab in the shop?
No, I think
Just
as far as we got was lab 4.
Okay, yeah, lab number 4, that was the farthest. If any of you didn't get to that point of completing lab number 4, that is okay. What I'm going to be doing in order to facilitate your life, we're just going to be doing like all the basic circuits from all these labs. Like for example, when we come to this one, which is the Zener diode, okay? So you see a simple circuit that I replicated on multisim, but in this instance, instead of using multisim in the computer, I mean, yes, you were going to be using multisim in the computer, sorry, but instead of downloading multisim, what you are going to be doing in this instance is that you are going to use multisim online. Okay, so I'm going to show you how that looks. Right now on the screen, you have multisim online. That way, you don't even have to download any software. And just by opening a web browser, you will be able to simulate the circuits that I'm going to be pre-building for you, because that way that also save you time of learning what is it that you are supposed to do. I mean, in order to build the circuits on a simulator. So I'm going to build them on the simulator, and I'm just going to show you how to change, like in this case, a few parameters. And then you are going to be able to complete the table that you have on your workbook. So once more, I'm showing you here the circuit. So in this instance, you have RS, that is the source resistor, or the series resistor from the source. And then you have your Zener diode, which is rated for 6.2 volts. And you have a 470 ohm resistor, which is acting as a load. In this instance, you will need to fill two different tables. You will have to fill this table, which is with different applied voltages. So this power source is going to change from 4 volts, and then you are going to fill in the blanks all the way up to 16 volts. And also in today's demonstration, I'm going to show you how to change that voltage. It's very simple. And then you are going to use a switch that I added on the simulation, that little switch in here. I'm gonna run the simulation so you can see it. And you are gonna be able to complete the second part of the table just by doing a simple click on the switch that you see on your screen. And that is going to turn on the Zener diode, and you are going to be able to complete everything else. So back to the lab, like in the case of the Zener diode lab, all that I'm going to be asking you to do in this case is just to complete these two tables and the graph, okay? With the simulation, we could do, you know, because it's a very powerful software, do the dual voltage DC power supply, but we're not gonna get into that because it would be way more complicated. I mean, I have done it in simulation, but it would be more complicated for you. And because we don't have as much time, at least with the Zener diode, with the simple voltage regulation, you are gonna be able to get the most important part, which is learning and knowing that the Zener diode that is connected in parallel with the load is going to be acting as a voltage regulator. Okay, so that will pretty much cover the main objective on the course outline. After that, as we keep going, we are going to continue, you know, with simple circuits, like for example, with the SCR. And like in the case of the SCR, okay, up to this point, what I want you, I'm gonna see like what's the limitation. I'm still learning how to use multisim online. has used it a lot extensively, like in the computer. But now that I discovered that it can be done online to simplify the process of having to download the software, I'm gonna see like how much we can condense, excuse me, the SCR lab and also the other two labs that I'm gonna be asking you to complete to have you completed, like the RC timer lab. That's gonna be another one that we are going to do, but also in a condensed version. And then the last one, I mean, like, I'll see how much I can condense, Dia can try it. And that way, each one of these labs is not gonna take you more than half an hour to complete. But, but what I want you to keep in mind that each one of these labs that I'm gonna be asking you to do is gonna be in a condensed manner. It's not gonna be the whole thing. Because I want you at this point in time just to be able to get the basics. Okay? So anyways, today I prepared for you so I could show you and I can give you the time to go ahead and do it online. And that way I'm gonna stay online also in case you have questions, you know, in case you are having any difficulties. I want you to be able, I wanna help you to complete the Zener Diode lab, okay? So which is the first part of the Zener Diode lab. So I'm gonna scroll down back to that part. Oh, okay, scroll down too much. And if you're having any troubles listening or if you still need to complete part 4, please let me know. Okay, so I guess that I better do this. Okay, so let's begin with the first part, okay? So that is the circuit that you have. Do you have access, just quick question, do you have access to your workbook? Like if you have access to your workbook, I'm gonna give you a minute so you can go and get it in case you don't have it with you. And once you have it, please let me know.
I got it right now.
Oh, you got it right now. Okay, perfect. Anybody that needs time to get it?
I got mine as well.
Thank you for letting me know. Okay, so now anybody needs time to get it or everybody else is good?
I got it.
I'm at work right now on break, just watching this.
Oh, okay, I got it. Yes, you can go and get it, okay? So let me show you pretty quickly, guys. This is not gonna take long. So I'm going to share, okay, on Iconestoga, I wish I were able to share my screen live as I'm doing things online. Okay, so you let me know if this works or not, please. So I'm gonna share it on Iconestoga. I have my, you can see my Iconestoga online at this point. I mean,
Yeah.
whenever I change something on the screen, can you see it as well? Like that I change?
Yeah.
Okay, perfect. So I'm gonna view it as a student. So what's gonna happen is, this is your course right there. I'm gonna click on it. And then I'm gonna go to the content. Under the content, I will scroll down to the Zener regulator, the online class, okay? Once I click on that tab, I created like a new page, which is called the Zener Diode Lab Simulation. I'm gonna click on that page and there's a hyperlink. On the hyperlink, I'm gonna click on it. And like in this instance, I didn't even have to open a new page. Within the same platform of Iconestoga, you can see that the circuit is loading. Okay, so I'm gonna make it a little bit bigger to make it easier for you to see. Put a little bit more center on the screen. Okay, there we go. Okay, so here on this interactive simulation, I already like put all the labels for the different values that you will have to fill in. Beginning, like if you go back to your table. Okay, if we go back here, we see that we are going to have to find the ERS. Here at the bottom, it says it's going to be a meter value, but because of the, I'm still learning, as I said, you know, how to use the simulation property. I created it in such a way that instead of being a measure value for ERS, it's going to be a calculated value. But that is embedded, or that's why that you see that right here at the bottom, it says that ERS is equal to I times R. So we are going to be using this I, which is the current flowing through RS, and we are going to multiply by 150 ohms in order to get ERS. Okay. However, because the advantage of having the simulation that we don't have in the shop is that in the case of the simulation, it can measure like very, very a small amount of current. In the shop, we had to calculate, let me show you that once more on the table. We had to calculate these values for IRS and also for IRL. In our case, I'm not going to be asking you to calculate those values. Those are going to be measure values. Why we are going to measure those values? Because indeed, I'm going to jump back into my simulation, because indeed those values, IRL, okay, I put a probe there and that thing can measure like microamps. It can measure actually picoamps. So however, like in my case, or in this case, in the case of this lab, I will only ask you to only record values which are on the microamp and up. You know, like if you see something as nanoamps, just write a 0, okay? If you see like that something is like whatever, like 525 nanoamps, just, I mean, don't take it into consideration. It's such a small value that for our purpose is irrelevant. We'll just put a 0 on it. Do I make myself clear there?
Yes.
Yep.
Thank you. So let's keep moving. Now, the way in which we are going to do this lab is that here you can see that we have a play button. So we are going to run the simulation right there. As soon as the simulation starts running, I can open and close that switch. At first, we'll have to fill these values, which are the results with no regulation, which means, in other words, that our Zener diode is not connected. That was the first part. You know, not regulation means the Zener diode is not connected. And the 4 different voltages that we are going to use is going to be 4, 8, 12, and 16 volts. What I'm going to show you next is how to change those voltages right here while the simulation is happening. So if I want to change the voltage, I just will click. This is one simple click on the 4 volts sign. And right underneath where it says 4 volts there, I'll just click again and it's going to be highlighted and just type 8. And just click outside of anywhere, you know, in the circuit, and it's going to be changed automatically to 8 volts. So if I want to change it to 12, I'm going to do the same thing. Go back. Just type 12 and click outside of that box. And now it has been changed to 12 volts. This, by the same token, when I want to change it to 16, okay, I just will go and click 16 and I will change it to 16 volts. You can also notice that there's a slider at the bottom. I prefer not to use the slider because if I do, my voltage, I mean, yes, I would be able to control my voltage from there, but it's gonna be changing like my voltage dramatically, okay? I mean, you can do it from there if you want, if you find it easier. As you can see there. But myself, I just prefer to type the numbers. I want to change my voltage to. Now, you were able to notice that as I was changing my voltage, okay, like for example, let's keep going there with the 4 volts. I have my 4 volts apply. So I'm gonna be able to calculate. I have here 6.4516 milliamps, just use Ohm's law. And with the 6.4516 milliamps, when I multiply that times 150, I'm gonna be able to know what is the voltage drop, ERS, and that's gonna be the value that you are going to write down on your table. That's gonna be at 4 volts, your ERS, or the voltage that you have right at this point on the resistor. The other values, as I mentioned before, IRS and IRL. IRS here. Okay, sorry. IRS here is going to be like your 6.4516 milliamps, and IRL, which is the same amps because it's a series circuit in this instance, right? And then also you are going to be able, like this probe here, this other voltage, it is the voltage, this voltage, I'm not asking you to calculate it. I was able to introduce this other probe that is able to measure the voltage through this branch appropriately, or in other words, this voltage, ERL, it is the same voltage that you are being asked to provide for ERL. So I decided to leave everything, you know, like consistent with the diagram that you have, because that way it's going to be more simple, easier to complete. Okay, so, and as I mentioned before, okay, so you are going to be able to change this now to 8 volts. Let's see what happens. I want you to look at these values when I change it to 8 volts. Something which is important, while you are changing the voltage, please make sure that the simulation is running. If you stop the simulation, I'm going to show you what's going to happen, okay? Like if I stop the simulation and I change it to 8 volts, then I'm going to see this message. It says out of date. And of course it's out of date because I changed my voltage and I didn't run, or I stopped my simulation, okay? Or I mean, right, so I'm gonna have to rerun the simulation, and that's what I do in order to regain the values, the correct values at the new voltage, which in this case is 8 volts. So you can see that in this instance, your milliamps changed, and also the voltage drop that you have through the 470 ohm resistor was changed. And you will be able to notice that when you change again to the 12 volts, that all these values are going to change once more. So what you want to prove at this point is that indeed, as you are changing the voltage, you will always see a different voltage drop through this resistor, because Ohm's law, you know, dictates that when we have a series circuit, the resistor that has the highest resistance is going to have also the highest voltage drop. And that way, Ohm's law is not broken. Now, something interesting about the Zener diode is that the Zener diode is connected in parallel with the resistor. And once we close the switch, and this is important, guys, the simulation has to be running. Please don't stop the simulation. And then you can just click on the switch. Once you close the switch, did you see what happened there? It went from 9 volts to 6.2 volts. So that means that regardless of what is the applied voltage, regardless of the changing voltage that I have on the power source, I'm going to be able to keep a constant voltage through the load because the excess current is going to flow through the resistor. Okay, so, but I'm going to let you, I mean, I'm just going to give you the time so you can go ahead, So you can play with this.